Hey guys, welcome to Bar Z. My name's Stan, and today we're going to go through a something I acquired for one of the surface grinders. It's an overhead wheel dresser, and I've got it right here. Thought you guys might want to take a look. And this is a nice heavy cast iron, or cast aluminum, I'm sorry, cast aluminum dresser. It's got a micrometer down feed. It's got a rack and pinion right here to move the diamond in and out. And within the unit, it takes looks like it takes a 3/8 diamond. Let me fling this thing open. So you've got a diamond that goes right in here, and that's for the down feed, and then obviously your wheel's there, and it traverses across the wheel and cuts your wheel and trues it up for you. Now you will notice that the diamond is behind the wheel center line. Your wheel is spinning this direction. So it, all your debris and everything's going off to the side here. But that's really going to save your diamonds being behind the wheel center line. And you're going to get more consistent results with the diamond always being in the same place. Because when you land the diamond on a mag plate, you never get it in the same place twice doing the wheel. But there's some special requirements. I want you guys to notice one feature of this. Back here there's a lug. There's a hole in it. And that sits above the spindle, because this clamps to the spindle right here. So you got this one around a slitting saw right there, and there's a clamp bolt here that squeezes this down onto the spindle. But then I want you to take special notice of that little lug right there, and we're going to talk about that. And I got some pictures drawn on the board, and we're going to go over what has to happen to make this as accurate as just plopping it down on a diamond and going. So let me set this to the side, and we'll take a look at these strange looking lines on the board. Okay, well, what we've got here, this lower line represents the axis of the machine. This rectangle here represents your mag plate, which should all be equal, very parallel. And typically what we do is we just plop a diamond right here and traverse across the wheel, and that's automatic. It makes it parallel with the machine, and your wheel is dressed perfectly for doing flat work and flat grinding. Well, you know what? We're not putting a diamond down on the plate anymore. Now we're putting it above. You know, we've got this little fella up here on top, and we're dressing across this way up on top of it. Now what's so good about that? Why do we want to do an overhead dress as opposed to just sticking it on the plate that we know is accurate and know is parallel with the axis of the machine? Well, if you're doing a lot of flat work and you're in the middle of a project, you can just leave your work. Well, let me tell you what has to happen first. If you're using the conventional method and you're in the middle of a project, you're in the middle of a large grind of flat work, and your wheel loads up and your results are going downhill fast, you're not going to make it through the job without redressing. You need to stop, pull the part, drop a diamond on the table, lower the spindle down to the diamond, make your cut, get your wheel all cleaned up and ready to use again. Pull your spindle back up, clean everything up, clean your part, put your part back on the machine, come back down, touch off, and go back to work. Now what I just described is, takes 5 minutes maybe. All right, but if that happens over and over and over, it adds up. Let me tell you what happens with the overhead dresser. You're in the middle of your work, you've got a micrometer down feed for your diamond. You give it a few thousandths of down feed, and traverse across the wheel a few times, get your wheel clean, and let's say you took a total of 5 thousandths off of your wheel. You go to your tower, your down feed, give it your 5 thousandths, you're back where you were, and you're back to work. You never pulled apart, you never had to switch stuff out and do all that cleaning and swapping around. So if you've got a lot of flat work to do on some large pieces, an overhead dresser is a wonderful thing. Now, let's talk about the rack and pinion in this guy. as you can see, when we pull this lever, our carriage and our micrometer moves in and out here. You know, so it's not the axis of the machine. It's different, but it needs to be parallel with it. So what if this thing runs at this angle? What's going to happen to our wheel? Our wheel's going to dress at a slight downward angle, and our wheel's going to be shaped like this. You know, and when we're grinding, what's going to happen to our grind? We're going to only be touching at this edge right here. If we're traversing this way, you know, our work's going to be matching that like this, and we're creating a wedge and working our way across at an angle when we traverse this way. But you know what, when we're coming the opposite way, you're only touching one spot. You're not getting all that contact, and you're not getting that good averaging as you're passing across on your flat work. You want that wheel flat. You want to create that averaging because every part of the wheel has a job. The leading edge is doing the heavy cutting, and as it passes across with each step over, you're getting all that averaging of that wheel and making that, you know, creating that surface and getting it flat and parallel, everything else. So that axis has to be adjusted very finely, and I'll point you back out to that jacking bolt in the back. This eyelet right here, this eyelet, and that's you just put, you know, 2 nuts and a bolt, fine threaded bolt down to the spindle, and that just ever so slightly tips this unit, and that it's going to help keep it in alignment too because it's always there. But it's going to you know, tip that diamond in the axis of this rack and pinion until it matches the axis of your machine. And I can't think of a good way to do it and measure it. Thankfully, that jacking bolt's right out where you can get to it, and it's just going to be a matter of putting it in, making a dress, doing a little grinding to see which edge is leading and trailing, and make very fine adjustments until it gets dialed in, until it's actually working properly. And then after that, man, you don't want to touch that thing. It's like after grinding your chuck, man, you don't want to pull it. So it's going to be a kind of a install and be done with it kind of thing. All right. But let me get it installed on the machine. I picked this up a few days ago. It's made by Boyer Schultz. It's more modern than my machine, but they never changed the spindle size, the spindle OD. So this is going to clamp onto my spindle. And then that jacking bolt's going to have to be, I need to either make one or buy one. So let's get it on the machine. A few things have to happen here. If you recall, mine has a dust collector. I've got no way to get a dust collector there, so I need to get a dust collector mount on there. And then I need to get a place to put my coolant. All they gave us was a little, looks like a 3/8 hole with a 1/4-20 set screw there. But I want to put a steel plate there so my little mag base can stick on there. All right, but let's go get this on the machine and check it out and look at it a little bit more. Okay, well, we've got it fitted for the first time, and just wanted to check it out and an overall fit and get it put in. You can see our lug here for the jacking bolt lands on a tapered surface, so I'm probably going to file a very small flat spot for that bolt to land on. The jacking bolt I'm going to use isn't the exact one. This is a 1/2 inch, but this is a coarse thread. I'm going to go pick up a fine threaded bolt, which I don't have, and I'm actually going to drill and tap that. That's just a through hole, and I've got enough meat there to drill it 1/2 inch, or drill it and tap it 1/2 inch, and then put a single jam nut on it. And then the bottom of the bolt, I'm probably going to put drill it and put a copper insert in it so it doesn't gouge into the spindle. So I'm just going to put a little bit of copper, a little bit of soft copper in the end of that bolt, and use it as a jacking bolt. I was kind of anxious to get it working and see if it actually worked, but let's run the machine, and I'm going to pull it across. No contact. I've already done this once, and I'm just pulling that handle right there. I'm going to give this about a thou of down feed right here on the micrometer. And there I'm dressing wheel. All right, so how simple is that? You're in the middle of your work, you're down on your work, and you're trucking away and you want to, shave 1/1000th off of your wheel. Do that down feed there 1/1000th, then do the hand wheel 1/1000th to make up for it, and go back to work. So there's still a few things to overcome. Again, this is aluminum, cast aluminum, so my coolant here on the mag base isn't gonna stick. This is my regular rig. It's a little Noga Mini Cool with a mag base, and so I need to put a block of steel right back here on the back. I'm probably gonna take it over the mill this flat, and put a little steel plate on there, bolt it on, and that'll give me a place to put an indicator or my coolant, either one. And then I need to work out the dust collector too. And here's my old dust collector rig. It's got a slot in a steel fabricated tube, and I need to get that stuck on there so I can do my pickup. And then there's a little flat tab right back there on the back, that little piece of flat bar, and that's where I clamp my rubber flap, which is kind of consumable. So the rubber flap's there to help scoop everything up into the dust collector. So that needs to be fitted. So this needs to get drilled and tapped. That needs to get drilled and tapped for the jacking bolt. And then I need to get my coolant set up back over here, or a place to set a mag base. Right now, none of this is magnetic, so I measure off of this all the time. Just plop an indicator on and measure apart, tram a table, tram apart, whatever. So, I use it for checking quite often. All right, but that's the first fitting on there. Okay guys, well, I'm back from the store. I went and picked up my jacking bolt that I wanted. That's a half 20 and a jam nut. So I've got a jacking bolt for the back of that thing. And part two, we're gonna finish accessorizing the thing and get it installed for the last time after we get all the machine work done. After we do the, thread the hole for the jacking bolt, get our dust collector attached on one side, and get a place for us to land our mag base for the coolant on the other side. And then we're going to dial the thing in and jack it around a little bit. All right, stay tuned for part two. Thanks for watching part one.